Welcome to this video with me, Duncan Williamson, in which we're going to be talking about anomaly detection in Excel and in Power BI. In Excel, we're going to be using third-order derivatives. Sounds grand? Not really. And in Power BI, we're going to be using its built-in anomaly detection utility. Anomaly detection using differentiation. The first method we're going to explore to detect anomalies in data uses third-order derivatives, and we'll use Excel to do that, where the first order represents the rate of change, and the formula for dy dx, first order derivative, is this one. The second order derivative gives us acceleration, the formula for which is this one, d2y dx2. And the third order, which seriously is known as the jerk, is this one. Now, if you've never done differentiation before, you have. If you've ever done rates of change, let's say change from period 1 to period 2, and express that as a percentage, that's a first order derivative. Didn't even know that, did you? And then we step up to order 3. You'll see, it really isn't difficult. It's arithmetic. Anomaly detection in Power BI, on one of their blog entries, they say this, that anomaly detection helps you enhance your line charts by automatically detecting anomalies in your time series data. And it also provides explanations for the anomalies to help with root cause analysis. With just a couple of clicks, you can easily find insights without slicing and dicing your data. You can create and view anomalies in both Power BI Desktop and the Power BI service, but the steps and illustrations in this video are from Power BI Desktop. And you can click on that link that I've put in the slide there to go to the entire blog entry. The data then, they are monthly sales for a souvenir shop at a beach resort town in Queensland, Australia, for January 1987 to December 1993. It doesn't matter that they're very old data. And I took these data from the ebook using R for time series analysis, time series point 2 documentation. And again, click on that link and it will take you to that ebook. The data in Excel then, when you copy the data from R, as I did, it comes out, as you see on the left, the Excel table on the left, the blue table. By using Power Query, I unpivoted those data into the format that you see on the right. You need to unpivot the data in order to carry on with what we're about to do. And this is what I found. Firstly, because of the way the data are in the blue table and the way they come out in the orange table, you'll see that I needed to generate a calendar table that you see in the bottom left, month and number of days, and I also needed that for the derivatives. I'll explain that in a second. But here's my outcome then. In Excel, the third order derivative, the values, which you don't see here, but you will in a second, on a graph, they look like this. And I've highlighted the anomaly values in the red circles you can see there. This is how it's done. Days, month number, actual sales, the first order derivative using this formula, this one, minus this one, divided by the difference between these two, which is 1. In every case, it's 1. So you'll see in the formula that the denominator is always 1. 1 to the power of 1, power 2, power 3. The second order derivative is this one. And the third order is this one. So the results we're getting are here. They call it the rate of change. Actually, it's not quite the rate of change that I do. I won't demonstrate that here just because of time. But if you do month 2 divided by month 1 minus 1, expressed as a percentage, it gives you nearly this. So it's not quite the same, and again all the way down. They are very nearly these, but not the same. And the second order, the third order derivatives are as you see there. And what I did with this, purely, is it arbitrary? Don't think so. But what I did was I set the threshold for these derivatives to be my anomalies. And here's the first one where I've got a derivative value that's less than -2 or greater than +2. And you'll see overall, I found 10 anomalies in these data. Into Power BI, here's how the data are. I simply copied and pasted the data from Excel. And because of the format of the data, I had to use DAX concatenate to create the date and date 2 columns, because anomaly detection in Power BI needs to have a date formatted x-axis on the line chart you're about to see. And here are the concatenate formulae. And why have the 2? Why not have 3? Well, in Excel, with concatenate, you can concatenate 255 different things if you need to. That's extreme, obviously. But in DAX, you can only do 2 at a time. So I concatenated the number of days, the days in a month, and the month. And then I had to do, for date 2, use this first date and concatenate them with the year. And when I format that column, date 2, as a date, then that's what I need for the x-axis on the line chart. So it's a bit of extra work, but you can see it's not difficult. Then in Power BI, I then created my table, very simple table with date 2, column 1, and sales. Actually, it says summer sales. It's actually just sales day by day in column 2. And the line chart shows the expected range, by the way, the grey shaded areas, and our actual data. And it found only 3 anomalies. Where I found 10, Excel found 10 using third order derivatives, Power BI found 3. And how do you find them? They don't just appear. You click on your line chart and then go over here to the analysis magnifying glass, and you'll see there's an anomaly there. Just click on that to select it. And what this does here is it allows you to format the dots and the anomaly. It's set at 70% sensitivity. You can make that larger or smaller, and depending on which way you do that, it may give you more or fewer anomalies. I set it at 70, I had a very quick play with it. It stayed at 3 the whole time, so I've left it at 70. And down here, simply the colours. But if you go to the magnifying glass, an anomaly is grayed out, it means that your data are either in the wrong format or not appropriate. It knows already, it can do nothing with them. When you mouse over these anomaly points, it shows you the value at that point, the expected value at that point, and the expected minimum and maximum, again, at that point. And this is why this is an anomaly, because it's expecting 14.3 and it found 45.1. Expecting, found, expecting, and found. So they are the 3 anomalies. Go and mouse over all of the data points to see how near or how far away they are from being classified as an anomaly. Let's take a look at the Excel and Power BI files now. Here in Excel, I'm sharing this file with you so you can see it. And if you're familiar with Power Query, you can simply go and look at the query. You can see there are 2 of them there. Go and have a look at that and see what I've done. If you're not familiar with Power Query, you need to do a little bit background work on that to find out to try and understand exactly what's going on. Now, as far as the derivatives are concerned, you only need the third order. You don't need the first 2. So you could, I don't recommend hiding things normally, but if you've done them, like I have, you can simply hide them there. Alternatively, don't do them. It really is as simple as that. There's the formula. That's the formula. Explore it, and Notice because I've hidden it from the graphs as well. Don't worry about that, it came back. And that's it. So I manually highlighted the anomalies. Or I could have used conditional formatting. I didn't because I was doing this on the fly. So I was deciding what my cutoff point was, and then I decided it was plus and minus 2. But anyway, you can do you can use conditional formatting as you wish. Why have I done this here? I've done this, created this extra column, which helps me to put the anomalies on that chart there that I've already showed you in the PowerPoint. And as I mentioned, it really is, as I've mentioned, it really is arithmetic. If you open that cell, yes, because it's a Excel style table from Power Query, you have the structured language there. But apart from that, you can see, look at the formula on the slide, it's this value minus 3 times this value minus this value all over, in this case, it's months. So I've used the number of days in the month on the row that we're in to determine the denominator. It was 1 on the formula sheet. It was 7 in another example you'll find in this file, and it's 3128, 3130 in this file. It all sounds a lot more complicated than it is, but no, give it 10 minutes. By the time you'd spent 10 minutes on this, you'll have understood it. I'm sure about that. So I found 10 anomalies. Raw data, order 1 and 2, order 3 with anomalies, and that's it. What do we do with that now? What's the significance of that information? Now you have some idea of the anomalies, and actually what you can see is this is multiplicative data. Is getting wider and wider. The amplitude, if that's the right word, is getting bigger and bigger, and so therefore, taking an overall average, you're bound to find anomalies there using the third order derivative method. If you, let's say, chop the data, just arbitrarily, let's say at point 40 or 50, and run it again, would you get the same anomalies? Think about that. Because that might explain why Power BI only has 3 anomalies, because it's using a completely different algorithm, and by the way, which you can explore in that blog page I've shown you the link for, and you can go and explore how their anomaly function works. Completely different from this one. Well, anyway, look, there we are. I don't say either of these is better than the other one, but that's the Excel one. Let's go and have a quick look at Power BI. Here are the data. There's my formula. Ordinary, everyday, copy and paste from Excel. Click on date over there, and here's the DAX. Click on day 2, and here's DAX for day 2. And again, you need to explore why I've used 2 but not just 1. Look at the documentation for DAX, and you'll find it can only do 2 things at a time. Apart from that, what else can I say? Put it back to page view. Put it back to page view. There's your table. There's your line chart. There's the further analysis. And there's find anomalies. You can see, for example, forecast is grayed out. We're not using forecast, but it's grayed out. And I did mention earlier on that if this is grayed out, it means the data are not appropriate, or you've done something wrong maybe. There you are. Explore this file as well. If you're familiar with Power BI already, you'll find this is nice and straightforward. Go and have a look at the blog entry anyway if you're interested in the functionality behind it. But there we are. So now we've got 3 anomalies. There's the mouse over. That's the information there. And what do we do with that? Well, here we're saying these are not anomalous, whereas now they are. Is it always going to be the case, here's a question for you, that multiplicative time series will have anomalies if you explore the whole data all at the same time. All right, I'll leave that with you then. That's anomaly detection in Excel and in Power BI with me, Duncan Williamson. Thank you for watching, and I'll see you in the next one.